disc or spherical shape. Clear? So this I is the moment of inertia, where I is the moment of inertia of this pulley, and omega is the angular velocity, I omega square. So this term we have to add. Clear? So this term we have to add. Now half of m1 y dot square plus half of m2 y dot square plus half of I this omega omega square, what I can write, or w square, what I can write. So when this elongation, this length is y, this will be from, so suppose because this pulley, rotation of this pulley, that ये यहाँ पर था, सपोज दिस पॉइंट, जितना ये डिस्प्लेस करेगा उतना ये भी करेगा, वो सपोज यहाँ से यहाँ तक आ गया. So this linear displacement is equal to, again this theta angular displacement. Okay, so again if it is a theta and omega, we know that v equal to r omega, so where v is the linear velocity. Clear? So here linear velocity is what? Y dot, and r we are getting radius, this is r, and the whole square. So one term, this term will be added. So when the pulley is heavy, in the expression of kinetic energy, this term will be added, and बाकी जो वो सेम ही होगा. Potential energy equal to minus m1 g y minus m1 m2 g l minus pi r minus y. Again if you solve it, Lagrangian L equal to t minus v, you will get the same expression. So you solve it, and y dot, you will get y dot equal to m1 minus m2 multiplied by z divided by m1 plus m2 plus m1 plus m2. One term will be added, that is वो क्या होगा, I by r square. I by r square will be added. So this is just, you can write two-step problem, construct the Lagrangian, and you will get this solution. So here you see, when the pulley is heavy, the concept is when the pulley is heavy, then the acceleration, this is nothing but acceleration. Okay, so this acceleration, downward acceleration of this mass will be lesser or greater as compared to the light pulley. When this pulley is heavy, this term is added in the denominator, so the acceleration will be less. So this is the thing we have to remember. So this is the problem how to pulley, in case of pulley system. And we also solved the spring mass system. Now we'll take more problem. Let's see. Okay, so this is another example. The example is your cylinder rolling on an inclined plane. So a cylinder, suppose an inclined plane is like this. This is a cylinder. So this is suppose rolling like this. Okay. So suppose this is the inclined plane. The angle of inclination is suppose beta. Okay. And here is a cylinder. So this is a cylinder, and having radius is r. So this cylinder is, center of mass is here. It is rolling in this way. Okay. So when it is before starting motion, it will, the point of contact will be here. So when it is after some time, this will be suppose at that position. Now the point of contact will be here. Clear? And the center of mass will be here. So center of mass is moving in this way with suppose a displacement from here to here. The displacement is suppose x. Clear? What will be the velocity of the center of mass will be x dot, And here when before starting this point of contact is here, so after some time maybe this point of contact will kaha hoga, suppose here, and the new point of contact is here, this angle is theta, and here I said that equation of constraint, and here in this case the point of contact must be fixed for rolling motion. So x dot का जो velocity है इसका direction like this, and your r theta dot का जो direction होगा ये इस तरफ होगा, and when it is equilibrium then the point of contact will be fixed, okay. So this is the case, we have to find out the acceleration of this cylinder or equation of motion. So now how many general degree of freedom will be there? How many, any guesses? How many degree of freedom will be there? Only one degree of freedom in this direction, or in this direction what degree of freedom is equal to your 1. Now what will be the generalized coordinate? Generalized coordinate क्या क्या हो सकता है? Either displacement of the center of mass, or another the angular displacement. When it is coming like this, two variables are there, one is x, another is theta. Theta will be changed हो सकता है. So your generalized coordinate is equal to either I can say x or theta. Degree of freedom 1, generalized, so coordinate x or theta. You can choose any one. And you see, so what will be the kinetic energy? T equal to half of, suppose the mass of the cylinder is m, half of m x dot square, because of this linear motion of the center of mass. And another motion, rolling motion, another motion होता है, क्या होता है? With an angular velocity, this is moving with an angular velocity, suppose omega. So another I omega square, where I is the moment of inertia of the cylinder. Clear? So now you see omega we have to write down in terms of x and theta. So v equal to that v equal to r omega. So here v equal to r omega. Here r will be the radius, omega will be क्या होगा? Omega will be theta dot, and this will be x dot. So your x dot equal to r theta dot. So what I can write is equal to half of m x dot square plus half of I, omega is nothing but theta dot square. So I can write half of m x dot square plus half of I, theta dot I can write x dot by r whole square. So this is the kinetic energy. And what will be the potential energy? So I will measure the potential energy. So before measuring, so I have to set the reference level. Suppose this is the reference level. When the cylinder is at this point, the potential energy is 0, suppose. And when the cylinder is at this point, the potential energy, what will be this distance, center of mass, from here to here? If this inclination is beta, this inclination will be beta, okay, also will be beta. So from this to this distance is x, and this is beta, so it will be just like x कितना होगा? X, this will be base, this will be perpendicular, x sine beta. So from here to here the distance will be x sine beta. So your potential energy V equal to, and below the reference level, minus mg x sine beta. So your Lagrangian L equal to T minus V is equal to T half of m x dot square plus I x dot square by r square minus a plus mg x sine beta. Clear? So for the Lagrangian equation of motion, we have to find out x double dot d by dt del L by del x dot minus del L by del X is equal to 0. So d by dt, here dot we have with respect to x dot, we have to differentiate it. It will be m x dot for here plus I by r square, I by 1/2 will be here, so 2 gets cancelled, I by r square x dot. So x dot I can take common, x dot, and again इसका differential with respect to time, so x double dot m plus I by r square and minus this, so minus with respect to x, so mg sin theta, that is equal to 0. So calculation you can do yourself. So here the x double dot is equal to, we have got mg sin beta divided by m plus I by r square. So this is the expression. This is the expression, the acceleration of the cylinder. Now, so in your examination, so this is general condition. In your examination, maybe in case of cylinder के जगह क्या दिया होगा? In case of cylinder के जगह, it will be given that okay, suppose a sphere is rolling on an inclined plane. Then what will be the same? So what factor will be changed? This concept will be same. No need to do again all this calculation. Just if you know this formula, you can write this formula in any other cases. Like suppose for sphere, what factor will be changed here? Everything will be changed except the moment of inertia, because when we consider the cylinder and moment of inertia, we considered it is I. So what will be the moment of inertia of a cylinder or of a sphere? So if in case of a sphere, the I will be your 2/5 m r square, where m is the mass of the sphere. So I can directly put x double dot equal to mg sin theta sin beta and divided by m plus